Today's lesson is how to graph from a point and the slope. So here are directions. If we know a point and the slope, the first thing we will do is plot the point. Then we will go ahead and write down the slope as two different ratios for direction. Another way to do this is to consider the sign of the slope. We want to make sure we know that positive goes up and negative goes down from left to right. So again, we read graphs left to right just like we're reading a book. So if it's positive, I want to make sure my line's going up, and if it's negative, I want to make sure my line's going down. The next thing that we will do is start at that plotted point. So start at the point plotted. Use the slope to move and plot additional points. On the line. Use the whole graph. So you want to plot as many points as you can possibly fit. Since we're using a computer, it's a lot easier to draw a straight line, but when you're doing this on paper, you really want to make sure you're hitting all the points possible. And then last is that you are going to connect the points using a straight edge if you're doing it by hand. And then, of course, make sure to put arrows on both ends to show that the line goes on forever in both directions. So let's take a look at this example here. I know it goes through the point 1, 3, and it has a slope of -3. So first I'm going to take one of these points and put it at 1, 3. So my slope is -3, so I can write that as two different ratios. I'm going to add in a text box here so I can show a little bit of work. So -3, first of all, is not a fraction, and I do want it as a fraction if I'm going to be counting slope on a graph so that I can count my rise over my run, my change in y over my change in x. So remember, I can always make things a fraction by putting them over 1. So I could say it's a -3 over 1, or you could say it's 3 over -1, because those would both equal -3. So that means that I could go -3 as my vertical shift, which would be down is a negative direction, and then 1 in the positive direction, which would be right, or +3 vertically, so that would be up, and then left. If you don't like thinking of it that way, some people don't, the other thing is to just make sure, again, a positive slope is going up and a negative slope goes down. So if I know my slope is negative, I know that the line has to be going down from left to right. So you may just want to say, okay, how should I move to make sure the graph is going down? So my next point, if I grab a point here and I start where I left off at the point plotted, I want to go, let's try down 3 and right 1. Down 1, 2, 3, and over 1. And you can see again, if I follow this from left to right, it's going down, so I know my slope is negative and I've done it correctly. Let's do another one. From this point, go down 1, 2, 3, and over 1. And I think I can still fit one more in there. Down 1, 2, 3, over to the right 1. And I could also fit one in this direction by going up 3 and left 1. And again, if I look at it as a whole, that is a negative slope. And now I'll take my line and place it connecting the dots. And again, if you're doing this by hand, you would want to use a straight edge. I'm going to try to get this as close as possible. And I think that looks pretty good. And now I can answer some questions. My x-intercept right here is at parentheses 2 comma 0. Make sure it's an ordered pair. Make sure you're using parentheses. My y-intercept is up here. That's at 0 comma 1, 2, 3, 4, 5, 6. F of 2. So remember, if it's in parentheses, that's your input or your x. So if x is 2, what's y? Well, if x is 2, that's right here. Your y, or your output, is 0. If f of x is negative 3, what's x? So they've told me what f of x equals. I want to know x. So this is an x. That's y. If y is negative 3, so I go down to negative 3 on my y-axis and I look across. Oh, I have a point here. It looks like x is 4. So if x is 1, 2, 3, 4. Oh, no, I counted wrong. I'm sorry. My x value is 3. 1, 2, 3, down 1, 2, 3. So x is positive 3. Okay, going on to the next page. All right, 6, 4. So I take a point and I'm going to plot it at 6, 4. So over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4. So we are right about there. So I can consider this slope as positive 2 over 5 or a negative 2 over negative 5. Either way, I know the slope is positive, so I have to make sure my line is going up. Unfortunately, because I'm at the very edge of the graph, I can't really go up 2 and right 5 because then I'll be off in question 3. So instead, I have to go down 2 and then left 5. So negative direction for both. Down 2, 1, 2, 3, 4, 5. And you can see that overall the graph is going up, so I do have a positive slope. And we can keep going to get more points. Down 2, left 1, 2, 3, 4, 5. And I don't have quite enough room to go left 5 again, so that is going to be it. I'm going to take my graph, my line, make it go through all the points. All right, I think that looks pretty good. How about my domain and range? So following this graph from left to right, well, it goes all the way left and all the way to the right, so my domain is going to be all real numbers. Range, bottom to top, well, it's going to be the same thing because it goes all the way down and all the way up. So all real numbers. My zeros, remember your zeros are your x-intercepts. So right there, I have a 0 at negative 1, 2, 3, 4. So that's a negative 4 in curly brackets. X-intercept, well, we just said there's a 0 at negative 4. So that is also my x-intercept, just written as an ordered pair, negative 4 comma 0. And my y-intercept, well, it's not a nice number, so I can approximate what it is. I would call that 0, maybe 1.6. Again, we're just giving an approximation here. And f of negative 4, so negative 4 is my input. Let's see, x is negative 4, 1, 2, 3, 4. My output is 0. And my y value, f of x is 2. What is x? So y is 2, my output is 2. What's my input? So if y is 2, we go across, it looks like x is 1. When x is 1, y is 2. So on the next example, I've got the point 2, 4. So I'm going to go ahead and grab a dot and put that at 2, 4. And then I see that my slope is 0. And anytime I see a slope of 0, I think about my special cases, flux and Hoy. And when I see 0, that's Hoy. A horizontal line has a slope of 0 and an equation of y equals a number. So I know if it has a slope of 0, it's going to have to be a horizontal line through that point. Now also, when we think about the slope of 0, keep in mind that it's going to be 0 over 1. So that means I go up 0 and over 1. So up 0 over 1, up 0 over 1. That's how I get a horizontal line. So my domain, left to right, all real numbers. My range, bottom to top, is going to be, well, just the y value, which is 4. My zeros, well, it never touches the x-axis, so that means there are none and no x-intercepts. And the y-intercept is here at 4, 0, 4. F of -3, well, it really doesn't matter what this number is, no matter what x is, y is always 4. And this last one here, I've got an undefined slope at -1, 4, so I'm going to plot that point at -1, 4, right about there. And when I see undefined slope, I think about VUX. So a vertical line has an undefined slope, and the equation has to be x equals some number. So here's my vertical line, which means my x values, my domain this time is just the x value of -1. My range, bottom to top, well, that's everything, so all real numbers. My zeros right here at -1, which means my x-intercept is -1, 0, and it never touches the y-intercept. No y-intercepts. If f of x is -6, what is x? So that's saying if y is -6, so if my y is -6, what's x? Well, it's always -1.